Alright, this is Mr. Gillum, and today we are going to solve by factoring. So, what we're really going to do is going to learn about the zero product property, okay? And what it basically says then, if you have two factors, you can set each of those factors equal to 0. As long as you understand that anything multiplied by 0 is 0, okay, you can use it to your advantage, okay? So it doesn't matter. If we have an equation a times b equals 0, if a is 0, it makes the equation true, or if b is 0, it makes the equation true. All right? So, I mean, let's just pretend we had a factored little part here. No matter what's in here, in this parenthesis, if it's equal to 0, this 0 times whatever this is, it doesn't matter, is going to equal 0. So x plus 5, if that's equal to 0, if I put negative 5 in this answer right here, I have 0 times whatever this is. That makes a true statement. Or I could plug in negative 2. Negative 2 plus 2 is 0. 0 times whatever this is will make a true statement. Okay, and so what the zero product property actually says is once you have factored terms, you can set each of those terms equal to 0 and find your solutions. All right, so here's how we're going to solve quadratic equations today. Okay. First, we're going to set the equation equal to 0. This is the most important step. If you don't do this step, okay, you're going to be very unsuccessful. Set the equation equal to 0. Then you're going to factor. All right, and we practiced factoring yesterday, and we're going to practice factoring some more today, and then we're going to use the zero product property. So what we're going to do is actually each factor is going to be set equal to 0. And then when I solve for my variables, and there's going to be more than one solution, okay, those will be my solutions. All right, so what we're going to do is this, okay? Got some example problems up here. The first thing you always need to do is make sure it's set equal to 0. All right, and because we already spent a day factoring, I'm assuming everyone kind of has the idea of what factoring is. Okay, two numbers that multiply to get negative 14 and add up to 5. All right, now I've done quite a few of these before. All right, so I'm going to say, since it's already set equal to 0, I'm going to factor my expression. I'm going to say positive 7 and negative 2 both multiply to add up to negative 14 and add up to positive 5. All right, and if you're not sure, you can always FOIL it. So let's just FOIL it just to make sure I did it right. Okay, and it does equal x squared plus 5x minus 14. That's equal to 0. Okay, but the benefit of having it factored is this. I'm going to go ahead and erase that. What I just did there, it's unnecessary. Okay, the nice thing about having it factored is this. Once you have your two factored terms, you can set each of them equal to 0. So I could say x plus 7 equals 0, or x minus 2 equals 0. And you're going to see when I solve, x equals negative 7, or x equals 2, when you add 2 to both sides. All right, when you plug these in, you're going to get two solutions. Negative 7 squared plus 5 times negative 7 minus 14 should equal 0. Let's see here, that's 49 minus 35 minus 14, and it does work out. And if I plug 2 in, 2 squared plus 5 times 2 minus 14. 4 plus 10 minus 14 is in fact 0. So you get these two solutions here. So the benefit of factoring is that you can solve equations much easier, okay? Much easier. Okay, and I know we haven't talked about how to solve quadratics very much, but it's going to be much simpler to factor than it is to use a quadratic formula. So let's look at another one, okay? So basically what we're doing is this. We're setting equal to 0, factoring, and then setting each of those terms also equal to 0. Now, I'm going to go through this one a little quicker. I think we kind of get the idea. I need two numbers that multiply to get 30 and add up to negative 7. All right. I'm going to go ahead and say 10 times 3 is probably going to be my best bet. I'm going to say negative 10 and positive 3. Because I just have x squared out there, I know my x can go in front. That is equal to 0. And if you're not sure if you did it right, you can always FOIL it out to see. But I know negative 10 times 3 is negative 30, and negative 10 plus 3 is negative 7. So now I got my two terms. I'm going to set each of those terms equal to 0 in itself. And I'm going to solve for x. X equals 10, or x equals negative 3. Okay? These are my two solutions. X equals 10 or x equals negative 3. All right, so this one is actually a perfect trinomial square, where I notice that this is a perfect square and this is a perfect square. All right. However, I can just factor it like normal. Two parentheses, set it equal to 0. I'm going to say -5 times -5 is going to equal positive 25. So I'm going to say -5 here, -5 here. These add up to -10, which is good. So x minus 5 equals 0. Okay. Now, you still set each term equal to 0. And what we're going to say is, obviously, x equals 5, or x equals 5. So what we're going to say is x equals 5 multiplicity 2. Okay, actually that's going to come in handy here in future chapters, understanding that's multiplicity 2. If we would have got 3 factors of x minus 5, x minus 5, x minus 5, just pretend we did. All right, if I had another one out here that was the same, I would have multiplicity 3 if I get the same solution 3 times. All right, and so on. And that's how we're going to write it. But let's go into a more challenging example here. It says x squared plus 18x equals -81. The problem with this is that it's not set equal to 0. So what I need to do is add 81 to both sides. Then I'll have my 0 on my right hand side and life will be easy. Life will be good. Now that I have it set equal to 0, I can factor. I know that 9 times 9 and 9 plus 9 are going to be good for me here because 9 times 9 is 81. 9 plus 9 is 18. So I'm going to say x plus 9 equals 0. Therefore, x plus 9 equals 0, or x plus 9 equals 0. If I subtract 9 from both sides, x equals -9, or x equals -9. And so what I'm going to write is x equals -9 multiplicity 2. All right. Let's take a look at one final more here. One more final problem. And once again, I have n squared plus 5n equals 24. It's not set equal to 0 yet. So what I'm going to begin doing is subtract 24. N squared plus 5n minus 24 equals 0. Now I need two numbers that multiply to get -24, add up to 5. I'm going to say 8 times -3 equals -24, and 8 minus 3 equals 5. I'm going to say n plus 8, n minus 3 equals 0. So n plus 8 equals 0, n minus 3 equals 0. And I'm going to solve n equals -8, or n equals 3. Okay, and those are my two solutions. So basically what we're doing today is we're factoring again, okay? After we set the equation equal to 0, we're factoring in, so we're setting each factor equal to 0.